So in this day, I'm going to report to you the Kruskal Wallis test, or also we call the Wallis Edge test. So what do we mean about Kruskal Wallis test, or what we call the Kruskal Wallis Edge test? Kruskal Wallis, this test is used to compare three or more independent groups. This is a non-parametric test which does not require normal distribution. This is alternative for the F-test ANOVA in parametric. So it means that this test is used when we want to compare the three different test methods was used in a test, okay, or in the independent variables, and it is slightly similar to what we so called the F test or the ANOVA. So these are the formula for this test or the H test. So H is equals to 12 over sample of open parentheses, sample plus 1, close parentheses, summation of um, Ri raised to 2, or what's called the initial rank over raised to 2 over initial sample of each methods minus 3 open parentheses sample plus the total sample plus 1, close parentheses. And here, um, where H is stand for the Kruskal Wallis test, and the number of each observation. 12 is the constant, and 12 and 3 are constant, or it's already given in the formula. Okay, so these are the example problem of the test. So consider the examination score of sample of high school students who are taught in English using three different methods. The method 1, classroom instruction and language laboratory. Method 2, only classroom instruction. Method 3, only self-study in language laboratory. Use the H-test at 0.5 level of significance to the test. The null hypothesis that their means are not equal. Consider the following data. So here in this problem, we are using three methods in test. So as what I have said earlier too, that this test is we use this test to compare the three different methods, or the three different methods that we use in a particular or a specific test. Okay, so here um, the sample test result of the three different methods. So as what I said to you, we have three methods were used in the test result. So we have the one, method one, we have the method two, and the method three. So for the method 1, the result is 94, 88, 90, 95, 92, and 90. And the number of observation is 6. For the method 2, we have 85, 88, 90, 80, 79, 85, 80, and the number of observation is 7. And for the method 3, we have here 89, 78, 75, 65, and 80, and the number of observation is 5. So here in this, as you notice in the we have here the R1 or R2 and R3. So later on, I will teach you how you able to get the R1 or rank 1, the rankings of each different methods. So this method that we use. So in order for us to get these rankings of each methods, first thing we need to do is to arrange the scores jointly from the lowest to the highest, then rank them. So this is the sample. Since we have 18 um, samples, the total of the samples of our observation is 18, so we need to rank them into the 18, or the result of the test result of each different method, so or the observation. So here as we notice, so we rank 165 because that is the lowest, 75 rank 2, 78 rank 3, 79 rank 4, 80, 80, 5, 6, 7, and so on. So as you notice, there are some similar result in each observation. So in order for us to get each similar um, ranking on each observation. So for example, here in the for the rank 8 and 9, so since it has the similar observation, what we are going to do is to get the mean of each rankings, which is the 8 and 9. So we need to add 8 plus 9 equals to 17 and divide it into 2. So the similar result is 8.5. So that's why they will having a similar ranking, and also the same goes also with the other. For example, here in the 13, 14, and 15, since they have different similar rank test observation, so we will add 13, 14, and 15 in order for and divide it into 3 in order for us to get 14. Okay, so this is the result, okay, of each ranking. Okay, so here in the for the met for the ranking for the method one, the and after that we'll arrange it into that on the table. Okay, so for the 94 we have 17 and so on. For the ranking one, for the method one, we will get the extract its summation. So the for the because later on we will use it in the on our computation. So for the ranking one, we have the summation of for the rank of the method one, we have 89.5, and for the summation of the rank of the method two, we have 57.5, and for the summation of the method 3, we have 24. 24. Okay. So solving by stepwise method. So solve the problem. Are there significant differences in the average score using the three different methods of teaching English? So we have here two hypotheses, the null hypothesis and the alternative hypothesis. So there are no significant difference in the average scores using the three different methods of teaching English. And for the alternative hypothesis, there are significant difference in the average scores using the three different methods of teaching English. So so in order for us to determine the hypothesis, it's either the null hypothesis or alternative hypothesis. Let us get first or extract first uh, the level of the significance of the study. So the levels of significance of the study is 0.5, and the degree of freedom is 2. So in order for us to get the tabular the level of significance, or the result of the level of significance of 0.5 at the degree of freedom of 2. So instead we will use the tabular table. In here we will use the chi-square, the chi-square. So which is the chi-square table. So which is the result is 5.991. So here is the example of the chi-square. So since we have um, the level of significance with the degree of freedom of 2, so we will so here, so as we notice, the result is 5.991. So um since we already get the level of significance of our study, so let us go now on our um, of our on the no competition. So as we said to you a while ago, the computation. So this is the formula of our computation. So h equals to 12 over n, open parentheses, and plus 1, the summation of the ranking of each method over the initial sample of the number of observation on each method minus 3, open parentheses, sample plus 1, and plus the total number of the sample and um, close parentheses. So these are the 12 over 18. So this is since the total sample is 18 plus 1 plus 1 cos pi is open parentheses 89.5 raised to 2 over 6. So since the sample the number of observation of the rank is 6, so that is 6, and for 57.5 over the 2 over 7, and 24 raised to 2 over 5 minus 3, open parenthesis 18 plus 1, close parenthesis. And the result of this is 12 over 342, open parenthesis 1335.04. So we get it by extracting the result of 89.5 exponential number of 2 over 6. So the result is 13.5.4, and 470.32 plus 115.2 close parentheses minus 57, and the result is the result of this and the result of of these is 67 point 67.458 and minus 57. So the result of the H test is 10.458. 458. So we have now in the decision rule. So if the H compound value or the Kruskal Wallis value is greater than the chi square tabular value, we need to reject the null hypothesis. So conclusion, since the H compound value of 10.458 is greater than the chi square tabular value of 5.991 at 0.5 level of significance with the 2 degrees of freedom, so the research hypothesis is accepted. This means that there is a significance difference in the average scores using the three different method of teaching English. It can be also concluded that the three methods are not equally effective. So that's all, and thank you for listening in my report.